Good evening, everyone, and welcome to another webinar at the National Library of Scotland. My name is Kenny Redpath, and I'm the Events Officer at the Library. Tonight, I'm delighted to be introducing Scott Duncan, who is here to give his talk called Weather and Climate, the Challenges. Scott grew up in the Cairngorms National Park in the Scottish Highlands, where he experienced all sorts of extreme weather. Indeed, I can just imagine what it must be like just now with all the snow going around. This exposure to Mother Nature from an early age brought about his interest in weather and climate development. Scott is now a professional meteorologist based in London, primarily forecasting for energy and power markets across Europe, with a heavy focus on renewable energy. He's worked in various parts of the weather industry, including offshore, transport, and construction. He gained a first-class master's degree in meteorology. You can see how difficult I'm having with that one word. I need to think of the events that we're doing for what I can say. And climate from the University of Reading, with 1 year spent in the School of Meteorology at the University of Oklahoma. I found out just before meeting Scott that on top of all this career, he not only has this, he plays the flute, the Highland pipes, is a qualified ski instructor, and has Gaelic as a second subject, to name but a few things. What a fantastic, interesting CV. But before handing over to Scott, can I just say there will be time for questions at the end of the webinar. So get thinking and just type your questions into the Q&A function, and we will do our very best to get through as many as we can. Also, we will be sending out just a little poll asking where you are in the world and what the weather is like with you. So I hope you can take part in that, just a bit of fun. But for now, over to you, Scott.
Thank you very much, Kenny, and a warm welcome to everybody that's joining this evening for this chat on weather and climate, the challenges. It's an absolute pleasure to be teaming up with the National Library of Scotland to be talking about a subject that I find so interesting, and hopefully I can share with you some of the fascinating things that have been happening in both weather and climate over the last few years and in the future. So getting stuck in. Weather impacts everybody every day. We rely on weather forecasts more than ever, perhaps more than we realise. Extremes in weather patterns have large impacts, and we have great examples ongoing right now. As Kenny said, we've got snow blowing around most of the United Kingdom with something that's almost like Beast from the East from 2018. Also in North America, we're seeing very, very cold temperatures, sub -30 in some places. So weather is so important when it's extreme, and that's when we notice it most. But weather is often small talk. So on a day-to-day basis, you might be catching up with a friend and it's just something that's a passing comment. But weather is part of big industry now, and I'll be talking about that in just a moment. But weather's not just small talk or part of an industry, it's now becoming something that's very politically involved. So weather and climate go hand in hand, and it's not just small talk, it's now, as I said, becoming more and more important on a political scale. So changes in weather patterns affect things like ecosystems, the biosphere, and life itself for us human beings and everything that's on planet Earth. Climate change affects us all, and it will become a huge part of our lives over the next few years, especially. So basically, weather and climate is everywhere, perhaps more than you realize or more than you'd like to expect. But I'll just touch on some of the industries and some of the background processes in weather forecasting, which may surprise you. So I've got a few industries kind of labeled as pictures here. You might recognize Carol Kirkwood there if you're from the United Kingdom, a very famous weather presenter pointing at a weather map. And a lot of people are familiar with TV, news, radio, that sort of thing for getting their weather information. But the weather industry extends far beyond just knowing what's going to happen from day to day. I've got a picture of a snowplow right there. I think that's very, very topical for us in the United Kingdom right now, which is subject to very cold and snowy conditions. Basically, we've got key workers trying to keep the transport network safe, and they need to know the weather forecast every minute of every day. And I think that's a really important aspect to our lives that we might not appreciate when we're busy in our typical days. We've also got a picture of a plane there. If you're going abroad, you want to know if it's going to be sunny while you're lying on the beach, but also when you're on the plane, you want to know if your path, the flight path is safe. Are you going to avoid any thunderstorms, any unexpected turbulence, that sort of thing. Even the very flight path itself is dependent on the weather, and the amount of fuel your plane uses is dependent on the weather. I've also got a picture of a crane lifting some heavy elements up to height. Basically, if it's windy outside, you really don't want to be swinging a 2-ton structure 200 meters above other people's heads. That sort of thing is, quite expensive decision making. But I've also got a picture of Glastonbury there. Big events, large crowds. Event planners really want to know what the weather's going to do, if it's going to be muddy, and they can get the preparations underway. And race courses for cars, and even like ski races and all sorts of sporting events, they rely so heavily on the weather. And I think a lot of people can relate to that. But in the middle there, I've got a tractor, and agriculture is obviously a massive part of everybody's lives because we all eat food. Getting food on the table, that food has got its own story with weather and climate, and it's so important. So any changes in weather and climate is so important for us, even if we don't realize it, if it's not in our faces every single day. So the weather industry has become a big part of our lives, but it's not always been like that, or we've not been able to have the same reliance on forecasts as we've had back even just 60 years ago. So I'm going to do a quick technology timeline of weather forecasting. So in the 1960s, we had satellites, and that was our first observations from space. And that was really important just to get a grasp of clouds and weather systems and how they look as they go around the planet. And a few people listening today might even remember in person when Neil Armstrong set foot on the moon in 1969. So that's basically 60 odd years ago, and we're talking about our first observations from space, which isn't actually that long ago when you come to think of it. So in the 1960s, we also saw early computer development, and weather started to use these early computers in making forecasts. And by early computers, I'm not talking about your smartphones and your MacBook Pros and all these sorts of fancy gadgets. These computers were very, very basic. And just off the top of my head, some of these computers would only make a 1-day forecast, and it would take about 4 hours to make. So you've already missed a bit of your forecast by the time it's run, for example. A modern mobile phone or a smart device is far more powerful than a computer from the 1960s. But in the 1970s, we saw the internet, and that was important for many reasons. But for weather, it was the global exchange of data that was most important. Sharing information and weather observations from across the world helped us get a better picture of the weather patterns we observe. And that helps get those early computers off the ground with some sort of initialization. And then they could actually give a better guess at what the atmosphere was going to do next. So the invention of the internet was so profound in more ways than one. Then in the 1980s, we saw computer development gain momentum, but then we could get finer details with more powerful computing, and the global capabilities continue to improve. But in the 1980s, we saw a disaster, a nuclear disaster in Chernobyl. Many people will have heard of the nuclear disaster from Chernobyl, but whenever we get a time of emergency, often we get innovation. So during the meltdown of reactor 4 in Chernobyl, we saw a nuclear plume go around the atmosphere, and basically scientists wanted to know where this plume was going to go next. And computer models were developed to track that nuclear waste area and see where it was going to go next. And the same physics and the same science and the same understanding is used today to track the atmosphere and what it's going to do next. And I think that's a really good way of showing how humans can react and change things as they see during a time of emergency. In the 1990s, we saw the digital revolution. So this is when mobile phones started to appear, and the internet was really becoming more and more popular. So during the 1990s, we actually had a massive storm in Europe. A few people might even remember this in person. So in 1990, on Burns Day itself, 25th of January, 26 January, we saw one of the most violent windstorms rattle through Europe. And the weather forecast at the time, there was a computer model, and it relied on 2 shipping observations out in the Atlantic. So the entire forecast hinged on just 2 observations. And this gave 1-day warning before this violent storm rattled through Europe, causing well, millions of pounds worth of damage and cost in human life. So even in the 1990s, we're talking only 30 years ago, we're talking about 1-day warning for such a powerful storm. So we've come 30 years and we're only 30 years to go until the present time, but you can see there's already some big differences in technology and how we forecast. In the 2000s, we then had the ability to have location-specific forecasts after this digital revolution. And that was very important for communicating how the weather was going to look on forecasts themselves. And since 2000, we've got more and more powerful computers. So we're talking supercomputers. And these things can produce so much data. We've got larger range of weather models, and the amount of data they produce is just mind-boggling. I mean, it's an enormous amount of data. We've got short-range models, we've got medium-range models, we've got long-range models, and they all look at different parts of the atmosphere and all work together in different ways. But for example, the latest Met Office supercomputer, which are one of the providers for the UK weather, it can calculate 1,200 trillion calculations per second. And just thinking out loud here, I can't even imagine that number every single second. I mean, how many calculations that is in a day is just absolutely mind-blowing. But then I can almost hear people asking the question through this virtual conference saying, well, if you've got these really, really fancy computers, you know, why are you still getting the forecast wrong? Why is it, you know, why is it not perfect? And there's a really good question, and there's a good answer for that. I think with the technology booming, even just in the last 60, or especially in the last 30 years, expectations have shot up as well with the technology. And I'm just going to now touch on some of the challenges we face, even with the fancy computers that we have today. So predicting the future is challenging. And I always like to say that when somebody says, what's it like to be a weather forecaster? And ultimately, that's what you're trying to do. Try and tell somebody what the atmosphere is going to do at a specific time and place in the future. So the atmosphere is chaotic, and that fundamentally holds so many challenges. I mean, chaos in its definition is complicated, and it's random. And this actually then ties me on to this chap in the top right there, a mathematician called Edward Lorenz, who lived from 1917 to 2008. He predicted that there's a certain point we can no longer see past with any definition or any statistical skill in forecasting, which I thought was absolutely fascinating. I heard about this at university. I thought the better your computers get, the more you know about the future, and surely you can just keep going, but that's not the case. This hypothesis was then followed up by Kerry Emanuel from MIT. He's a professor in the atmospheric science department, and their research shows that the limit of weather predictability is around 2 weeks. And this is really close to the original estimate by Lorenz, pictured there in the top right. So it's amazing that we can only see 2 weeks into the future, but then some people will also say, well, you can't tell me what's going to happen tomorrow when I'm having my barbecue. You can't tell me if the shower is going to hit Edinburgh or Glasgow. So we're talking about large scale weather here, like beast from the east, or is it going to be a pest from the west? We can have a typical understanding of the air mass 2 weeks out into the future, typically in a given setup. So in the forecasting, we've got this chaos and the complications with that, but we've also got this challenge in communication. And this is something that really fascinates me. And this is almost one of the reasons why I'm here today. We communicate hazards and uncertainty in a weather forecast. For example, we've had a lot of snow, as I've already mentioned it a number of times in the UK right now. So how much snow is going to fall? Where is it going to fall? Is it going to blow in the wind? Is it going to last for 1 day or 3, for example? Is it going to block the roads? So we've got to work out so many different types of hazards, and within the uncertainties of the weather models and trying to communicate the chaos, we've got to communicate different types of uncertainty. Where is it going to snow most, and when's it going to snow most? So it's almost a multiple fold challenge, I would say, as a weather forecaster. You've got to understand the data from weather models, which I've been talking about with their trillions of calculations. So understanding that as a scientist, but then also being able to communicate that effectively to people that are either non-meteorologists or non-scientific background. And I always think weather forecasting can be a bit like Chinese whispers. Even if you're quite confident in something happening, like cold air coming in and snow from the east, you can often get the message lost in translation if it's not hit on the head just right. So yeah, Chinese whispers and weather forecasting. If that's the only thing you take away from today, then I'll be chuffed. So I thought to show how weather forecasting has changed, or the improvement of weather prediction, I thought I'd show the hurricane prediction improvement in the last 20 years, well, 15 years here. Although we don't get hurricanes here in the United Kingdom, I know some people might be listening from the United States. I'll just talk you through this graphic really quickly. In the bottom right there's a swirl of cloud, and that's a brewing hurricane. And then in the top left of the image there, that's the United States. You've got Florida just up there in the top left of the image. And in 2005, we had this cone of uncertainty. So a 5-day forecast, at any point in that 5 days, you'd roughly know where the hurricane might be. And you give it this cone of uncertainty to show where it will be going. But as we go through 2010 to 2015, and then roll up to 2020, that cone of uncertainty has been decreasing. So in a 5-day forecast, we have now more confidence in where the hurricane might be by day 5. So that's giving life-saving information days in advance. A powerful storm like a hurricane, you need to know as soon as possible if it's going to make impact. So to get the numbers from this, nearly 350 miles of improvement in a 3-day forecast. So even 3 days out, we're talking about 350 miles improvement. That's nearly the distance between Glasgow and London. 3 days out, you know where the storm's going to go, if it's going to go north or south, for example. A 5-day forecast is now better than a 3-day forecast in the 90s. So only 30 years have passed. And what we're looking at 5 days away is what we could achieve only 3 days away in the 90s. And I think there's no price we can put on this sort of information. So communicating this information to the public and letting them see this, or this risk, and being able to make life-saving decisions 5 days ahead is priceless. So weather forecasting has evolved, and even though there remains some big challenges, as I mentioned, even 1 day in advance with chaos and all sorts, taking a step back really does reveal some of the amazing achievements in science. And actually one of my really good friends mentioned, his name's Simon Lee. He said there's a silent revolution in weather forecasting, always going on in the background. The improvements of weather forecasting, almost unnoticeable day to day. But if you step back and just see how things have changed over the last few decades, it's absolutely remarkable. So, however, weather forecasts are not the only thing that have been changing a lot in the last few decades. And that ties me on nicely to the second part of this topic in weather and climate. So we've probably seen so many graphs throughout our time, but this is one that's cropped up a lot. This is temperature versus carbon dioxide. So the temperature is represented by the colors. The warmer and warmer it goes on the colors, the warmer it means for the planet Earth. And the white line that's kind of following it along the bottom there, that's the amount of carbon dioxide, the carbon dioxide concentration in parts per million. And this runs from 1880 all the way up to the year 2020. So you can see the temperature is warming and the carbon dioxide emissions continue to rise. The Industrial Revolution began in the 19th century, and we're still producing a large volume of carbon dioxide and other greenhouse gases even today. And this is basically contributing to global warming, and we've all probably heard of the greenhouse effect in one way or another. So this is a fantastic little gift from NASA, actually, climate.nasa.gov. And it basically quickly explains heat from the sun comes into the Earth, and then some of it becomes trapped and then re-emitted back down to the Earth's surface. Basically, the more carbon dioxide in the atmosphere or greenhouse gases, the more the planet warms, or the lower atmosphere starts to warm. So climate change impacts. A warmer atmosphere can hold more moisture. So that's something that might be quite hard to get your head around at first if you've never heard of that. But a warmer atmosphere means basically it can hold more moisture. And basically the biggest impact from that is it can rain heavier if the atmosphere is warmer. Basically, if you think about a thunderstorm, for example, they can really pour. They can hold a lot more moisture than a typical winter shower, for example. Heat waves are becoming harsher and longer, and there's a lot of science showing that the weather patterns themselves are changing as the climate warms. And we've actually had some fantastic, well, fantastic is obviously the very wrong word to use here. We've had huge heat waves in in the Northern Hemisphere this last summer. Actually, Europe just recorded its hottest summer on record in 2020. Parts of Russia and North America also had very harsh heat waves. And there's also a lot of wildfires associated with that. We've seen a depletion of sea ice and glaciers. So the Arctic has been losing a lot of ice over the last few years, especially, and I've got a few animations just coming up on that. But the glaciers melting and any land-based ice then melts into the sea, and that can contribute to sea level rise. The sea level will also be rising because when the water in the ocean warms, it also expands from something called thermal expansion. And finally, there I've got the ecosystems and biodiversity collapse part of this. I mean, this is something I could talk about for hours and the different impacts of climate change, but obviously time is limited here and I don't want to go on down different tangents. Nature is declining globally at rates unprecedented in human history, and the rate of extinction is accelerating with grave impacts for people and species around the world. Human impacts and human-induced climate change is the main reason, and there is no doubt about that. The science is in concrete. I mean, as I said, I could spend a lot of time to talk about this, but I think the main part of this talk is to talk about the science and what's happening and how we can communicate this and the different challenges behind it. So, in my opinion, it's not too late to make a difference. Our climate change is changing, but what happens now? So, the next few decades are absolutely crucial, and unfortunately, there's no quick solution to climate change. If we took an ideal situation where there was no longer any carbon dioxide emissions getting emitted into the atmosphere, the global temperature would still continue to rise for the next few decades. That might be counterintuitive if you've never heard of this theory before, but this is linked to heat stored in the oceans. Beyond a few decades, in this ideal world that I mentioned, with no more carbon dioxide or greenhouse gases being emitted by humans, the climate would then start to steadily stabilize. Heat would gradually radiate out back to space. It's fantastic when nature has such an amazing restoring force within itself to eliminate excess carbon dioxide, and would eventually see a gradual decline in global temperatures. But we're talking over decades to centuries here. We can reverse our increase in global temperature sooner if we act now and limit our CO2 emissions. And I think many countries are now declaring a state of emergency for climate change, and acting upon this is of utmost importance. As you can see from this graph here, we've got different scenarios. So the different colors show different emission rates or emission scenarios and how quickly we react, basically. There's a lot of uncertainty on the outcome, and this really does depend on how we act as a species on planet Earth and how we act on cutting our carbon emissions. And I thought, instead of going through individual scenarios, just some reasons or perhaps some myths and challenges in climate change, and getting people on board with what's happening often can be stamped out by addressing some of the issues in the communication side. So I think one of the biggest challenges I see is the difference between weather and climate. And I think it's so important to know the difference. I've got two animations here. The one on the left actually is what we have now. This is Europe, and we've got cold air pouring in from the northeast, almost like a beast from the east. But on the right there, I've designed this climate change spokes diagram, which basically shows the monthly temperatures over the last 120 years gradually growing warmer and warmer. So the bigger the spoke and the warmer the color, the warmer the temperature is for that month as we go through time. So climate is essentially weather averaged over a long time. Climate is almost like lots of weather, clumped into one long and average kind of mass. And it's not defined by any single instances or any local extremes. And this is why I've got these two animations side by side. What we consider as normal weather in 2021, for example, it's not the same as what we would consider normal like 30, 50, or 100 years ago. So basically, weather can change in a matter of minutes, hours, days, or weeks. But climate change takes place over years, decades, centuries, and millennia. So I think if there's any main takeaway from this entire talk, is the difference between weather and climate. And it can really help solve a lot of arguments I see on places like Twitter, where people get carried away with different weather events that are going on. Basically, we've got a lot of cold weather right now, and we can't let a local snowy or cold episode detract from a global long-term trend. And I always chuckle to myself if I see someone say, oh, it's snowing, so much for climate change, or something along those lines. I mean, to me, that's almost me like saying, well, I feel cold when I step out of the shower in the morning. I mean, it's interesting, but it's not relevant in this global picture. And I think whenever something is happening, is it global? Is it a long-term trend? No, then it's not climate. I think that's the good way of thinking about it. But with climate change, one of the more important things which might affect the weather is the extremes. So I'm going to just now address, like, is the weather getting more extreme? And I think that's such a big question, and it's quite a difficult question to answer, but I'll give it a shot. So if our climate is changing and the weather patterns are changing, then our weather patterns could be getting more extreme, and we are seeing more extremes over the last few years. A warmer world means harsher extremes. So as I've mentioned already, with wildfires and heat waves, that can also mean droughts. But in some places, in a warmer atmosphere can hold more moisture, we can see more flooding. So it really does depend where you are. But with a warming world, there is the potential for more extremes, or basically you've now got a higher likelihood of exceeding extreme values. For example, if it's temperature, rainfall amounts, that sort of thing, or intensities, that sort of thing we're looking at. But as I've got a graphic here, which is summarizing one part of the world, which has been in climate news a lot in the last year. And this is looking over Siberia in Russia. And I've drawn on the Arctic Circle there just for reference. And then on the 20th of June, this place in Siberia recorded 38 degrees Celsius above freezing. That's 100 degrees Fahrenheit for our friends that use the Fahrenheit systems. And that was the hottest day in the Arctic since records began, and these records going back well over 100 years, hundreds of years. But then on the right there, we've got the 14th of January 2021, and it's minus 56.2, which is exceptionally cold. I mean, even for that part of the world, that is cold, and there's no denying that. And I think you can almost say, well, look, there's climate change on the left, and then, oh, there's not climate change on the right. But that's totally untrue. The extremes, you can still get cold. It does still get cold in the Arctic during the winter, but then the volatility of weather and the changes in patterns are making extremes more common. But the thing about cold extremes is that they're becoming fewer and far between and less frequent nowadays. And I think that's quite important as well. So this is something that can lead to confusion. It's something that I always battle with almost on a daily basis. So besides the fact that weather and climate can be confused, the world is not warming at the same rate across the globe. Some places are warming a lot faster than others, and some places are a lot cooler. So the graphs I've been showing have shown a global temperature change, but some parts of the world are showing a very different trend overall. And to me, I think the rate of warming, it's almost, to put it into a different way, it's like you're growing up with a sibling or a friend, and you don't really notice them growing up alongside you. But then if you've not seen them for a couple of years, or you go visit your grandmother, for example, and she's, oh my goodness, how much taller you are. That's what it's like with climate. You don't see the gradual trend, but some places are going to grow warm a lot faster than others. And I think, yeah, this part of the world, the Arctic and Siberia, is one of those places that's warming the most. And there is a theory that the Arctic is warming twice as fast as the rest of the world. True or false? I mean, I'm not going to sit and wait for anybody to respond, given that we're on a Zoom meeting here. But I've got a quick animation here which shows in red the Arctic warming, and then a white line which shows the globe. So I hope that's playing now. Since 1880 all the way up to 2020, you can see there's variations, there's differences in warming between the Arctic and the global trends. So the red line there has got a very different trajectory in the last 30 years, especially compared to the global trend over the last 30 years. So I did a bit of quick calculation there. Every decade since about 1990, we've been gaining about 0.9 of a degree in the Arctic. But the rest of the world average has been warming at about 0.2 degrees per decade. So the Arctic is actually warming about 3 or 4 times faster than the rest of the world. And the next slide here actually shows what 2020 looked like when you average the entire year and then compare it to what we consider normal. So a long-term period in the past, in this example is from 1980 to 2010. So you can see the Northern Hemisphere, especially around Siberia and the Arctic, has been far much warmer than it has been over the last, compared to the normal since 1980 to 2010. Actually, some places within Arctic were about 7 degrees warmer than normal. And you can see there are a few blobs on the map that are blue or the whites. That's showing that it wasn't actually a particularly warm year in 2020. But if we step back and look at the entire global view, I've just labeled that in the top right there. That's Siberia and Russia and the Arctic, locally 7 degrees warmer than normal. But yeah, there's parts of Canada there I can see, which were a little bit cooler than normal for the year. Parts of Antarctica, some parts of the Northern Atlantic as well, and Greenland. It wasn't a particularly warm year, but overall 2020 was tied warmest year on record. It was actually the warmest year on record for the Northern Hemisphere and all land masses. Yeah, so that just puts into perspective. You don't have to have warming everywhere for the global trend to be changing as much as it is. And it's good to point out that the world is just not warming the same. So why on earth is the Arctic warming so much faster than normal? I'm almost not surprised because I've seen this over the last few years. But so I'm just taking a snapshot during that heat wave in the Arctic. We were seeing temperatures well into the 30s or nearly 100 degrees Fahrenheit. And that led to a lot of melting ice. So that cuts forward to the 24th of October, and there's a lot of ice missing by the end of the summer. So when there's missing ice, I've got the graph there, which shows how much further than it is compared to normal. It's a lot lower. The gray lines there is the trend or the average. The ice melted a lot more than normal. And when there's missing ice, the sea surface then becomes exposed, and that can then benefit from warming from the energy in the atmosphere. Before, we wouldn't have seen the melting of the ice, and the sea would stay locked under this lid and would stay a lot cooler. And this is called Arctic amplification. And I've got a quick run through here. So if we've got a warmer atmosphere, or like we have seen, we've got a warmer atmosphere, this then melts the sea ice. There then becomes more sea water exposed. That water is then able to absorb the energy. So less energy from the sun is reflected back to space, because essentially ice is almost like a massive mirror. So when that energy comes in, instead of getting reflected to space, it gets stored in the ocean. And when the ocean stores that energy, it becomes warmer, and then more ice is able to melt, or it becomes more difficult to refreeze during the winter. So it stays open water for longer. And that then in turn exposes more ice, sea surface to the atmosphere. But then you've almost got this link back to the beginning, where you've got more warmth leading to more warmth, and it's a vicious loop here. So they call this actually a positive feedback loop. And I'm almost against the expression positive feedback, because it's basically meaning something that enhances itself. But positive almost sounds, well, it's got good connotations. It sounds like it's a good thing, but in my opinion, it should probably be called something more like a loop that's yeah, it should have another name, basically. One of the biggest myths I've heard is, well, the ice will freeze in the winter. And yes, okay, the sea surface will freeze again. As I said, it gets really, really cold in the winter. But there's another way of looking at this, and I've got another quick movie. So the sea surface extent of the ice is one thing, but the Arctic ice volume is another. And I'll just run that quickly again. So from the 1980s onwards, we've been able to record the depth and changes in ice in terms of mass and volume. And that's the most important variable we have in ice, not just the extent if we look down from space, but the amount of ice we've got. And even though the ice will freeze in the winter and then thaw in the summer, it's thawing a lot more in the summer. So it's melting a lot more than it's refreezing again in the winter. It's not being replenished basically during the winter months. And this is basically summarizing that animation from the 1980s to 2020. You can see that we're talking more like 20 or 30,000 kilometers cubed for large parts of the year in the Arctic ice volume. But now, even in 2020, so this is only 40 years difference, we're looking at, sea ice volumes getting quite close to below 10,000 kilometers cubed. And as I said, this is in 40 years, which is a rapid change. And this is all part of the Arctic warming, and it's all part of Arctic amplification. But the climate change rate, as I said, is not the same everywhere. And I've got a few countries here, and I know there are a few people dialing in from different parts of the world. And we've got like Finland here, we've got temperature trends, and you can see there's cold spikes and warm spikes, but the overall trend is warming. The United States is much more smooth, but it's still showing a warming trend. South Africa as well, warming trends. Brazil, Mexico, Pakistan, Lebanon, Chile, and the United Kingdom. They've all got their own unique climate signature. And finally, Turkey there as well. But this is where the Arctic amplification and countries within themselves have all got their own signatures. And if somebody gets confused with climate change, or it's not happening in the same way in one place or another, people will be able to understand that if they can see different countries, different parts of the world all experience climate change in a slightly different way. And this is why impacts are always different for different parts of the world. So the climate has always changed. This is just part of a natural process. This is something I hear a lot. And I agree, the climate has always changed. I'm not going to deny that. It's the rate of climate change that's really important here. So we've had very, very cold parts of our climate. We've had ice ages. We've had warm periods. We've had a time not so long ago. We've had the medieval warm period where you had farming in Greenland, for example. But in the last 100 years, we've seen this spike in temperature. So 1.2 degrees warming in just 100 years, which is absolutely profound. And it's very difficult for life on Earth to keep up with such changes in the climate. Smoother changes like the ice age to these warmer periods often happen over centuries or millennium. But yeah, we're talking, within a century for our very abrupt warming. Another big myth I get told about a lot is it must be the sun, because the sun is what changes the climate. And the sun is a major player in our Earth system energy budget. But I've got a graph here, which is again from NASA, comparing the solar output since 1880 and then the temperature trend as well. So the solar output there is in yellow and the temperature trend is in red. And I think we can see quite clearly that despite no significant changes in solar, actually a decline in solar output, we've had a very substantial increase in temperature. So it's not the sun. And I think climate change is almost a bit like what we're seeing in the technology and forecast industry. So we've seen massive changes in weather forecasting and improving weather forecasts. But day to day, you don't really see those changes. But in climate, it's the same. So if you look at the climate every single day, you don't really notice it changing from one day to the next. But if you take a step back and then look at what was it like in 1880, what was it like in 1950, and then what was it like in 2020, those snapshots, you'll be able to see it a lot clearer. So basically, this thing ties back in with what I was saying earlier. We can't let like a poor forecast, for example, detract from the advances in weather forecasting, or we can't let weather, like a small scale cold scenario, affect our opinion on what's happening around the globe. And that we cannot let many different things detract us from basically the larger picture. I think that's what I'm trying to get at here. So before I finish, I was actually going to move on to the final part of this presentation, which is all about COP26. And COP26 is something that's going to be spreading across our news a lot, especially here in the UK over the next few months. I can already hear people say, well, what is COP26? COP26 is the 26th United Nations Summit about climate change, and COP stands for the Conference of the Parties. And it's going to be attended by those who signed the UNFCCC, which stands for the United Nations Framework Convention on Climate Change, and it was signed by 197 parties. So many countries across, almost all countries across the world joining in for this climate debate. And where is it going to be? It's going to be held in Glasgow, of all places, at the Scottish Event Campus. And it's going to be held between the 1st and 12th of November 2021. It was actually postponed due to COVID, so fingers crossed things are okay to go ahead. Not sure if it's going to be online, but it's still planned to go ahead. So what sort of things are going to be discussed at this COP26 summit? Well, we should start with the last meeting. So the last meeting was in Madrid, Spain in 2019. And there were many unresolved issues. So that's often the start of the next meeting. What didn't happen since the last one? But basically, each nation had to come up with a plan to cut their carbon emissions for the next conference in Glasgow. And they've had a little bit extra time. So fingers crossed they've come up with something good. You know, presidents and prime ministers from across the globe will be reporting their progress from each country. And this is going to be a massive event for climate, but it's going to have global attention. And it's actually going to be the biggest summit hosted by the UK ever. It's the most significant climate event since the Paris Agreement in 2015. So all eyes on Glasgow when it comes to November. But why is it in Glasgow? Well, Glasgow has got a lot of things going for it when it comes to climate. So Glasgow is set to be carbon neutral by 2030. It aims to be one of the greenest cities in Europe. And it's got a great track record for hosting big events. A few people might have attended some of the Commonwealth Games events in 2014 or the European Gymnastics Championships in 2018. So it's a very ambitious city, and it's not going to be easy to meet these very ambitious targets by 2030. But what is going carbon neutral? So going carbon neutral is basically reducing carbon dioxide emissions by offsetting the remaining CO2 with technology or planting trees. And there are many fantastic, areas of research going in how we can reduce carbon dioxide. But as I've said, planting trees is in there, and that's basically nature working for ourselves. But as I've said, it is a very ambitious target for Glasgow. Glasgow is a CO2 heavy industry. It's got a transport network that dates back to the Victorian times. And if anybody's listening from Glasgow or has visited the city and they've used the underground, you'll know what I mean. So also social housing has got infrastructure that's widely out of date. So we really want to energy proof our homes so they're more efficient, so they don't use as much energy. Solutions have to be affordable. We can't have, a greener future that only people with money can afford, or if there's a transport network or people want to have access to bikes, and it has to be achievable on all grounds here for it to be going carbon neutral. It has to be robust and everybody can take part. So this kind of leads me up towards the end of my slide. I'm focusing quite heavily here on Scotland. Obviously, this is here with the National Library of Scotland, but many countries across the world are doing a lot on going carbon neutral or trying to reduce their emissions. Scotland's got a lot going for it, and it's a world leader in green energy. It's got 12,000 kilometres of coastline, and it's got enormous potential to harness wind, tidal, and wave power. I mean, I could probably make a joke about solar, because solar is obviously a source of energy, but Scotland doesn't get that much sunlight compared to some parts of the world. So some other countries doing a lot more on the solar front. But just to put things into perspective, the first 6 months of 2020, Scotland created enough wind energy to power all of its homes twice over. So Scotland's got quite a small population density as well, which is a good thing going for it. And the aim is to produce half of its energy from these renewable sources by 2030, with virtually no energy coming from carbon heavy sources by 2050. So going carbon neutral by 2030, but virtually no carbon footprint by 2050 is quite an aggressive tactic to get things done. So to get these things done, you need a strong government to support these decisions and the right mindset. Without going too much into politics, it's very important to be behind any project to get it done. So that's important. But Scotland's got world-class development and research facilities, and it's a world leader in low carbon industries, as I've mentioned, and it's building the first large-scale tidal energy farm, and that should produce enough energy for 1,750,000 homes. And Scotland last year planted 22 million trees alone. So these are all good news stories, and I think it's really important not to get too excited when good news meets the headlines and what Scotland's doing. There's a lot of doom and gloom, I think, in climate change, and I've seen a lot of it. I've been exposed to loads of different people, from the climate denier to the very strong activist, and there's a lot of in between where we've got to kind of meet in the middle. There's a lot going on. We can't deny the fact there's a lot going on to make things better for carbon reduction, but there's also a lot of work to do to kind of get all countries on board to do something very profound. So I think it's good to balance the books. Yes, the climate is changing, and there's a lot of things to worry about, but then there's a lot of opportunity and innovation going on. And I've just shared a few from Scotland. Every country's different, and I mean, social media is a great place to learn about new resources, and there's great websites. A quick Google and you can find out loads about what your country's doing, and just knowing what's going to be happening politically with the COP26 summit and who perhaps you're going to be voting for in the future, then you can really start to think about the bigger picture. And I think that's what I've been trying to do over the last year or so, and just build this kind of science and communication side of weather and climate, just so people know what's going on both sides of the fence. So that takes me to the end of the presentation, and it's been an absolute privilege talking today. I know it's been a quick tour of weather and climate, talking about everything from weather forecasts to tackling a global problem, but I'd like to personally thank Caitlin, Joe and Kenny, who've all been behind the scenes there at National Library of Scotland, to let me chat away about the weather and climate. But yeah, I'd like to take this opportunity to open the floor to any questions. And I'll hand that back to Kenny, I think.
Scott, thank you so much for such a educational, entertaining, and I think positive what I got out of that as well. That was really fantastic. Thank you so much from us to have you with us. Now, I'm joined by my colleagues, Joe, Caitlin, who are going to help me with the Q&A. But before we do that, Joe, I think you're going to give us some results from the what we sent out.
Yeah, absolutely. So I've got our weather poll, and lots of you have commented in the Q&A as well, letting us know where you are and what the weather is like with you, which is fabulous. We've got people tuning in from all over the world, as Scott said, which is wonderful. So we have, unsurprisingly, 59% of you are in the snow with us, digging yourselves out perhaps. I think we might need to be doing that by tomorrow. We have a few people, 14% is a bit sunny, but a bit cold where you are, so enjoy that. We have one extremely lucky person who has sunny and hot weather, so I think we're all jealous of you right now and very much looking forward to the return of that. And 7% are singing in the rain. So thank you so much for letting us know where you are and what the weather is like with you. And for the first question, I'm going to hand over to Caitlin.
Great. So Orlando says hello from Mexico, and he says, what is your opinion of weather control through high technology, Scott? Is it possible? Is it good?
That's a really good question, and I very quickly touched on carbon neutral and technology, but I didn't really talk about it. I'm glad it was brought up, so thanks for that. With this sort of technology, there's a lot of research going on, and I do find it hard as a scientist who's not actually focused on any of those industries to comment on it, because if I say something good or bad, it can actually, it can be important, and I wouldn't like to downplay anything. But I think there's so much research going into it, and there are very promising parts to the technology to reduce carbon in this way. So it's a vague answer, I know, but you know, I'm optimistic, and there's so much innovation, and scientists are working hard, both in research and in practice, and countries are implementing different strategies to do this, and it is working in some countries. But yeah, it's a good question, and it's a hard one to answer though.
Great, thank you, Scott. And I'll pass you on to Kenny now for the next question.
Scott, we'll go to Peter. Peter C. Thank you for joining us this evening, Peter. Peter's question is there a way besides what is absorbed by the oceans to reduce and absorb the total CO2 in the environment?
So is that if the carbon in the atmosphere is getting absorbed by the oceans enough?
I think that's
Yeah.
what Peter's asking.
Okay, I hope that's what was meant. So the amount of carbon dioxide that's going into the atmosphere is not getting balanced by nature. And in that example, when I said when we cut carbon completely, then we can start to see the restoring forces. And through, well, I mentioned trees, for example, but there are many other carbon sinks. And if we did cut carbon in, like completely, we would see things start to balance by nature through various sinks, including through the oceans and through trees. So it's all about what we're putting in the atmosphere not being balanced to what's getting taken out of it from nature.
Lovely. Super, Scott. Thanks very much indeed. Joe, over to you for the next question.
Yeah, thank you very much. I'm actually going to jump the queue a little bit and ask a question that I'm interested in, if that's okay. Hopefully everyone else will be as well. I hope
the other 132 people that are currently watching us, Joe, are not going to be too disappointed.
No pressure, no pressure. I'll do my best. You know, is there one thing, Scott, that you think as individuals that we could maybe do to have an impact? You know, often I think with climate change, it can feel overwhelming, you know, and such a massive problem. Is there one thing you think that we could all do to make a difference?
Yeah, I think, well, from my end is if people just understand and know what's going on, that is absolutely amazing, because just knowing that will influence how you make decisions, and people can make decisions for themselves. If I told you straight away to become vegan or to stop traveling abroad, I mean, obviously that's quite easy to say right now because there's no travel, but it's very hard to force these big life changes on somebody who's either not interested or doesn't know what's going on. And that's not from, you know, being ignorant. That's from everyone's so busy, and, you know, science and all these things that are running in the background. It's very hard to keep on track of everything, especially in this day and age. We've got a classic example of something of, you know, more pressing issue. So I think if anybody was to take any, like what they should do from me, it would be just arm themselves with evidence and know what's going on. So when it comes to decision making about how they want to conduct their lives or who they vote for, they know what they're talking about. They know some of the myths, or they're in the pub and someone says, oh, it's snowing and cold, so much for climate change. They'll know what to say.
Great, thank you very much. That's cool. Cheers. On to Caitlin.
So Rachel has asked, how much has the temperature risen by since pre-industrial level up until now in 2021, so current time? So
there's various bodies that have been tracking the temperature, and we're just shy, I think it's around 1.2 globally. There's lots of different benchmarks, and I've been looking at lots of different data sets. But I think in this question, the exact numbers, I know there's this big 1.5 degree threshold we're aiming for, and that's ambitious and that's great. But I think climate change is a sliding scale. Whether we achieve, you know, the 1.5, or if it's 1.4 or 1.6 or 1.7, like the lower the better, in my opinion. So it has changed and it's continuing to change. So the exact 1 point whatever is almost, you know, beside the point. It's important as a target, but it's a sliding scale, and the lower the better.
Definitely. Thank you so much. I'll just pass you on to Kenny now.
Well, we're going to Mexico. We're joined by Orlando from Mexico. And Orlando's question is, from your perspective, what is coming in this year related with climate and weather challenges? We have seen in Spain, for example, extreme weather with extreme cold and pretty warm in a small country like that.
That's a good question, because it kind of addresses the issue of, is it going to get warmer and warmer and warmer and more extreme every year? And the answer is no. I don't think 2021 will actually be as hot as 2020, but it's still going to be part of this longer term trend. And as Orlando's correctly pointed out, Madrid had exceptional snow. It was the deepest snow in 50 years and some of the coldest temperatures in decades. And even like what we've got here, you know, it's really, really cold. And there are other internal variability, like ocean dynamics, that can play a huge role in the weather across the world. We've got basically a change in sea surface temperature in the Pacific called La Nina, and that can actually almost act like an air conditioner for the climate. It'd have more impact when the climate was cooler, or you'd be able to see a slight cooling if it was staying stable. But because we're warming, it'll act just maybe not as hot as the previous years. So we've started 2021, as Orlando's pointed out, in different parts of the world seeing, very impressive extremes. We could see, an active hurricane season, or we could see an active storm season or snowfall season like we have. But it will still be a lot warmer than what is considered normal, pre-industrial, but it might not be as hot as 2020.
Well, it's certainly going to be a lot hotter than it is here in East Lothian in Scotland tonight, I can assure you for that.
Yeah.
Next question over to you, Joe. We've still got time for a few more questions.
Yeah, thank you very much. This one comes from Brendan, and I think it's a really lovely question. What is the most important and/or inspiring thing you learned at school to help you understand how the atmosphere works?
I think I might even mentioned it today, actually. When I was at university, one of the professors said to me, weather models, they're all wrong, but some are useful. So in weather forecasting on a day-to-day basis, making decisions, or even if it's just telling a friend what I think the weather's going to do, we're trying to use science data and weather models to predict the future, but we're ultimately at the mercy of these models to an extent. And we've got to work out when they're useful and when they're not. So that expression is something I often say like to friends that are not even weather. So I think hearing that was probably the expression that stuck out most in my mind.
It's amazing how something a teacher said, so many years ago can just really stick with you. I'm sure we all have something like that in the back of our minds. Thank you, Scott. I'm just going to pass over to Caitlin now.
Thank you. So Jasmine has said brilliant talk and fantastic graphics, and she's asking, what do you think the key lessons, challenges in science communications are so that we balance helping people to feel hopeful with getting the message of urgency across, which is something you touched on in your talk?
Okay. Yeah, so what was the best way of communicating using kind of like balances?
Yeah.
I think being exposed to data in a new way is something that I'm trying to do, to get the science in front of people perhaps that might not have seen it before, and that's something that's happened over the last year. And just being crystal clear on that. It's like a weather forecast. You might have the best forecast in front of you, but whether people act in the way that you want them to, or become prepared, then that's a different kettle of fish. Or for people that are maybe not familiar with that expression, that it might not make much sense unless it's explained in a certain way. So I think going ahead right now, weather forecasting and science communication and climate are almost the same thing. And I think trying to get back to the question there, the best way of communication is coming up with, well, for me, my objective is to come up with new ways of showing it and keeping up with the data so people know what's going on, and seeing it in a different way and reaching new audiences. Because I think there's a part of this world now that are very much involved with climate. They know what's going on, but there's a lot that are denial or don't want to know, and that's fine. They just might not have seen data in a certain way, and that's maybe that's my hope, to try and show it in a different way, to get people thinking differently, and that might spur on some ideas.
Definitely. We've heard some great feedback about how good your graphics have been from teachers as well that are hoping to use it. So I think you're definitely doing well on that front. And I'll pass you on to Kenny if you've got any more questions.
Yeah, just on that note, just everybody out there, this event is being recorded, so all the graphics will be there up on our YouTube channel in the next week or so. We've got time for a couple more questions, Scott. Next one is from Angela Foley Mel. Angela, thanks for joining us this evening. Angela says, any ideas, Scott, for how we wealthy industrialized nations can help much poorer developing countries to improve their carbon emissions?
That's a good question as well. So quite often the poorer countries are not the ones contributing to climate change. I was actually going to include more graphics about showing different parts of the world and their carbon emissions, but obviously time just doesn't allow to show that. So yeah, the poorer countries are, as I said, are not producing in general the same volume of carbon dioxide. They don't have the same carbon footprint. And that's actually, it leads me on to a very important point, that climate change, as I said, it doesn't impact the world in the same way or in different parts of the world. And it's normally the poorer countries are in places that are more susceptible to the extremes, the larger droughts or heat waves, for example. So when it comes to international aid, it's quite hard for me to comment on it as a scientist, but I mean, there's a lot we can do to support, different bodies that are working towards, disaster relief, because some places are seeing more intense, typhoons, for example, or harsher droughts. And it's hard to me to kind of shout out support chains in that. But I think the main point is that the places that are, the poorest places are often the places that are not contributing to climate change as much, or far less than the places that are wealthier, for example.
Okay, I think we've got time for one question from each of us before I need to bring the webinar to a close. I have to say that I've just had a look from Dorata from Finland, who says, thank you for such a lovely talk. Greetings from our igloo. There you are. I think Dorata, you are the first igloo residents we have had since we started our webinars at the National Library of Scotland. So I'm so pleased that you've joined us this evening. And over to you, Joe, for the next question.
Yeah, I'm just impressed you can get Wi-Fi in an igloo. I think that's great.
We're clever up there.
Absolutely. So our next question comes from Ailey McLeod, and she has said, do you think an increase in the global population is having a negative effect on the climate?
Absolutely. Yeah, so it's all about supply and demand. The population is booming, or has been booming since the Industrial Revolution as well. So that's the main need for carbon heavy industries. It was the most efficient way of getting energy. So the population growing is the biggest contributor to climate change, the demand from humans, and that's why it's called human-induced climate change. But also like the way humans are achieving their energy and getting like natural resources, it's having profound impacts. So I've talked about agriculture and changing the landscapes, and a lot of people will probably have seen documentaries by people like David Attenborough and how the natural world is changing because of the population changing. And if we had a far smaller population, the demand wouldn't be there on the planet. So we're basically putting a huge amount of strain on the planet, and so it's a really good point to make about population there.
Yeah. Thanks very much. Over to you, Caitlin.
So Mary has asked, in your opinion, do you think we're talking enough about the impact of climate change on our health? And if not, how can we incorporate that more into discussions and education around the issue?
Yeah, I mean, it's a few years since I've been at school. Climate change was kind of just talking about how it worked. But I think getting that information into schools is a great idea, and that's something I fully support. And actually, as it's been mentioned, a few teachers have been asking, and I'm thrilled to hear that people are using it in the classroom. I'm using data sources that are very reliable, like from NASA, for example. So yeah, I encourage anybody to use any graphics in classrooms. But sorry, what was the question again? I've gone off.
So it was asking if climate change had an impact on our health, and if so, how would these kind of discussions be brought about?
Yeah, so climate change does have an impact. So actually it ties back to the question that Ailey just asked about the population and its impact. So with carbon dioxide emissions and other pollutants in the atmosphere, there's a far greater rate of mortality from breathing difficulties and all sorts from that. So it's got health implications from that front alone, kind of direct impact from the gases and the change in the atmosphere and the kind of human activity. But there's lots of indirect consequences from, more greater floods, harsher droughts, as I keep mentioning, and more extreme heat waves and this heat stress and all that. So we need to adapt, and there's a lot of infrastructure getting built in the countries that can afford it, but that's not true across the world. So the places that are going to suffer most are those that can't afford to get air conditioning units in where it gets super hot. And there are more places that we can see in the world that are technically reaching a state of being, you can't live there almost because it's just too hot. So as a health risk, climate change is something that we should all be aware of as well. I was trying to include some of that, but I couldn't have time to mention all the different parts to climate change.
I'll just pass Kenny for the final question.
Thanks, Caitlin. Scott, this is something sort of directed at you for the final question, I suppose. It's Dave Wynne from Wales. Dave, thanks for joining us. And Dave's asked, I've noticed warmer and wetter winters over the last 40 years here in Cardiff. But what difference in climate have you noticed in your lifetime?
That's a good question. So yeah, warmer, wetter winters is something, you know, the British Isles has been facing. Last winter was remarkably warm, wet and windy. This year it hasn't been so. There's different reasons for that, and we don't really have time to go into seasonal forecasting and how the atmosphere works. But yeah, changes that have been happening in my lifetime. Well, I grew up in the Highlands, and winters when I was much younger they were snowier and colder. And now so much that the winters, ski seasons are actually really struggling. And also places I know, like in the Alps, there's been profound changes in the Alps, like alpine conditions, and glaciers are melting, and the seasons are just not what they were even 20, 30 years ago. So it's a really good point to make. It's wetter winters for the UK. It's very hard to say exactly if they're getting windier, or for example, if we're getting more frequent storms, but the general kind of lack of snow and the days where we don't get above freezing, what we call ice days, they're actually disappearing, and that's something that could become a thing of the past, in the next few decades, for example. It's very hard when you do have an extreme cold, because it can still get cold, which can always hide the long-term trend. But it's a good point he's making about the changes.
Unfortunately, I need to bring this webinar to a close, but I think somehow, Scott, not only will I say thank you so much for a great talk, I think we're going to have to get you back talking more on climate and weather and that M word that I will not say again in an introduction. Thank you. Thank you, as I say, Scott. That was superb. Can I also just thank my colleagues, Caitlin MacDonald, who set this event up, but as always, my colleague Joe Stevenson, for making sure these webinars go as smoothly as they always do. Joe and myself are back on Thursday, that's 11th February, when we are joined by award-winning writer James Robertson and cultural critic Valentina Bold, who are here to reflect upon Scottish writers James Hogg and Sir Walter Scott. That event will take place at 5 p.m. Greenwich Mean Time, so really hope you can join us for that. Finally, on behalf of the National Library of Scotland, thank you everyone who has joined us this evening. And whatever the weather it is like with you, wherever you are in the world, stay safe, be kind to yourself, and bye for now.